Here is an excellent example on transformation application. Problem before us is, if f of x is equal to x plus 2 times x minus 4, determine the x-intercepts for each function. Okay, so here we have different options. A is y equals to f of x, the same function. We know what the x-intercepts are. We can find from here, correct? Now these are a set of transformed functions. Here we have b, which says y equals to minus 2 of f of x. Then we have y equals to f of 2x. And then this is another transform function, f of minus x minus 1. Now, as you can see, when we transform a function, all the points will change. So, we have to see how the x-intercepts change and what are their image points on the new transformed functions in a different way, right? Now, let's look into this function, f of x, this. Let's make a rough sketch of this. So, let's say this is our x's. And so the roots are, or the x-intercepts are at x equals to minus 2 and plus 4. So let's draw a graph here like this, kind of. Yeah. For me, first I draw the graph, then I write down the points. It's more accurate that way, right? So this is like minus 2 for me, and this one is 4 for me, correct? So these are my x-intercepts which we are trying to analyze in this problem. Now, for f of x, we know what are x-intercepts? X-intercepts are point where these are my x-intercepts. What are x-intercepts? At x-intercepts we have y equals to 0, correct? So if I equate y equals to 0 or f of x equals to 0, then what should I have? To solve this equation, x could be minus 2 or plus 4. So for the first function, which is y of f of x, the x-intercepts are at x equals to minus 2. I'm writing 0 for y value. And at x equals to 4, correct? So as I've shown here on the graph, so this is my function f of x, correct? The idea to show this graph on the side is to show you what really happens on the graph and where the x-intercepts move and to get our answer. Now the second function is y equals to minus 2 f of x. So what will this minus 2 do here? It is a reflection and vertical stretch by 2. So reflection and vertical stretch by 2. So let's do it in a different ink. Reflection means this is going like up, it'll go down, right? So kind of like this, is it okay? And vertical stretch means upper things goes much higher, right? And the lower much lower, right? So reflection is this times this exact value, right? And it will reflect like this. For vertical stretch, I will do 2 times. So instead of here, my graph will start from there. And I know 0 times anything is 0, right? So these are my invariant points. Y value is 0. This only affects my y value, not the x value, correct? So I will have a graph which will be kind of like this. Is it okay? So you'll see my x-intercepts remain same. They don't really change, right? Therefore, I can write here as my x-intercepts remain same. They are minus 2, 0 and 4, 0. Now, this is one way of doing it. The other way of doing it is to see the transformed points. Do you remember that concept of transformed points? It was like this. In original function, if I have a point xy, and if we do a transformation, let us say my transformation is y equals to a times f of k x minus d plus c, then how will my point be transformed on the image? A and c actually affects only y, and inside points affect x value. So my image point actually will be, x will be divided by k, so I'll have 1 over kx plus d. And how about y point? It will get multiplied by a plus c, right? So a times y plus c. This is my actual transform point. If we apply this transformation to our points in the original function f of x, then how will they get changed? Minus 2 times f of x means x value remains same, right? There is no change in the x value, correct? K is 1 and d is 0. But the y value changes. It gets multiplied by minus 2. If you multiply y by minus 2 here, what will happen? 0 times minus 2 is also 0, right? It doesn't change. Those are invariant points. They don't change. Therefore, we have the same function. Does it make sense? So here, the transformation will be x remains same and y becomes minus 2 times y. Is it okay? If I do that, I get the same answer. Now let's look into this. Now here, what is happening? Here, x is getting divided by half. Do you understand? So here, the transform point is half of x, but y remains same. Is it okay? If y remains same, that means y is 0, right? Y remaining 0 means it is still an x-intercept. And the x-intercept should be at whatever is here divided by 2. So what should I expect? I should expect x-intercept at minus 2 times half or divided by 2, which is minus 1 and 0. And 4 divided by 2 is 2. So you get 2 comma 0. Do you see? They become half the value. That means, in a way, we can look into the original function and draw. So what is happening? Let's look into f of x for c, which we are trying to do in this color, okay, blue color. So this is at minus 2. This point will move halfway here. So this will come at minus 1. This was at 4. It will move halfway through. It will come here. Do you see that? All the points will come halfway. Do you understand? So when these 2 points, likewise, let's say this is 1 point here. This will come here, correct? That point is so far away, it will come to somewhere there, correct? Similarly, the vertex, which is so far away, it will come here. So we will have a function here, kind of like this. Do you see that? It's not so nice, but I think you can make it. Do you see that? So now my x-intercepts are at minus 1 and 2 because they come halfway closer to x-axis. So graphically and algebraically, I get the same answer. Do you see that? Now, let's look into this. It seems to be very complicated, but here, let's again go with transformation. If you see, there is no change in y, so y remains same, but there is a change in x. What is the change in x? It gets multiplied by minus and then you add 1. So x value becomes minus of the original value plus 1 and y value remains same. If we do transformation, if y remains same, that means y is still 0. If y is 0, it is an x-intercept. Okay? Listen to my words very carefully. If y remains same, y is still 0. If y is 0, that point of x is an x-intercept. Correct? Now, what happens to the x point? It gets multiplied by negative 1 and then add 1. So if we do that, negative 1 of minus 2 is what? Plus 2. And if you add 1, you get 3. So your x-intercept is 3, 0. How about this? Negative of 4 is negative 4 plus 1 gives me negative 3. So it becomes negative 3 and 0. Y remains same. So these are my coordinates of x-intercepts. So what did we find here? These are x-intercepts. Let me put this paper a bit on the top. Correct? So let me just draw a line here. So what are we writing here? We are writing x-intercepts for the functions, correct? So these are new points, correct? Can you sketch and verify this? We can do it. Let's redo our graph, right? So let me just quickly draw one. It's not very difficult. Draw fast. Don't worry about your mistakes. Original graph. This is my original graph, okay? Now, what is happening here? -1 means reflect on x-axis. And this minus will bring it 1 unit to the right. Is that okay? Fine. So, or I'll do it mathematically in a different way also. I'll teach you one more method. You can reflect and see your points. Here, what I will do this time for you is, I'll teach you another method. In f of x, I have a function x plus 2 times x minus 4. I'll rewrite this function with this transformation. Does it make sense to you? Let's try. So, we have f of x is equal to, I'll replace this x with, what is this? Minus x plus 1. Do you see? Correct? Minus, if I open the bracket, I can write this as f of minus x plus 1. Correct? So I'll replace this x with minus x plus 1. So what will I get? I'll get fx of x, instead of x I'm writing minus x plus 1, and I already have plus 2 there, times minus x plus 1, and I have minus 4 there, and this is equal to minus x plus 1 plus 2 is plus 3, and this is minus x plus 1 minus 4 is minus 3. Correct? So when is this 0? This is our transformed function. Do you see that? This is 0 when x is 3, and this is 0 when x is minus 3. So algebraically we did it. Let's do this algebraically. I'll replace all these x's with 2x. Let me just show you again. So my function y is equals to, I am replacing x with 2x. 2x plus 2 times 2x minus 4. Correct? I replace this x with 2x. Now where is the 0? Can you find out 0 now? 0 will be at 2 minus 2 divided by 2, which is minus 1. If I put minus 1 here, I get a 0, right? And if I put 2 here, 2 times 2 is 4, 4 minus 4 is 0. So that's another way of doing it. Correct? So try it graphically, this is algebraically, and that is using transformations. So you learned 3 different ways of answering this question. Perfect. I hope it clears many concepts about transformation, and it gives you a fairly good idea of how to answer such type of questions. Thank you.